Okay, now let's talk about charging and discharging of capacitors. Okay, so capacitor can be charged up by a battery. Capacitor also can discharge through a resistor. Okay, so first of all, we look at charging. We actually can take the capacitor and represent it like a water tank. Okay, capacitor is actually just like a water tank. And then the water inside the water tank is like the charge. Yeah, the charge. So look at this charging process. Initially, before the capacitor is being charged, it is neutral. Okay, it is neutral. It has no charge. And then the voltage across the capacitor is 0. No potential difference, no voltage across the capacitor. So we can say that initially the capacitor has 0 voltage, VC is 0. Charge in the capacitor also 0 because it's not charged yet. It doesn't store any charge yet. It's just like the water tank. It's empty. It's an empty water tank. No water inside. No charge inside. Okay. But after some time, after the capacitor is being charged by battery, now the capacitor has maximum charge. So QC is equal to Q naught. Last time QC is only 0. Now the charge in the capacitor is Q naught, maximum charge. And then the voltage across the capacitor also has the maximum voltage. It built up the maximum potential difference between the two plates. Okay, V naught. It's just like the water tank now is full of water, full of charge. Okay. So if you look at the graph, you can see for charging process, the charge before it's being charged, the charge is 0, and then after some time, after being charged up, the charge increase. The charge in the capacitor increase. Yeah, charge in capacitor increase. And when the charge in the capacitor increase, it built up potential difference across the two plates. So the voltage also increase. You see that? Increase exponentially. Voltage across capacitor increase exponentially. So it's just like an empty water tank. The water flow inside, yeah, being charged up, and then in the end, the water tank is full, full of water, full of charge. How about the discharging process? Discharging process, initially the capacitor is full of charge. Yeah, it's already just being charged up by the battery, and then the battery is being removed. Yeah, let's say I remove the battery. Now the capacitor is full of charge, full of voltage, potential difference. The charge in capacitor is maximum charge Q naught. The voltage across capacitor also maximum voltage V naught. Okay, it's just like the water tank is full of water, full of charge. Okay, and then you let the water out, and then let the water out means you discharge. Discharge. Now the charge is flow through the resistor. Yeah, discharge through the capacitor. What happened after discharge? The capacitor sooner the charge in the capacitor will drop to 0 again. Yeah, from maximum charge Q naught drop to 0. Okay, QC becomes 0. From maximum charge, it dropped to 0 finally. Okay, and then the voltage of capacitor from V naught, it will drop to 0 also. Yeah, because after discharge, there's no more positive and negative. It becomes neutral again. Yeah, the electron neutralize the positive plate again. So now the capacitor become neutral. When neutral, no more potential difference across the capacitor. So VC is 0. Charge in capacitor also 0. Okay. So if you look at the discharging graph, the charge from maximum Q naught dropped to 0, but it never really cut the. If you look at the graph, it never really cut the axis. Yeah, it just merely touching. The voltage across the capacitor also from maximum voltage V naught dropped to nearly 0. Okay, so you see the charging process. We charge from 0 to maximum charge, from 0 voltage to maximum voltage. For this charging process, if from maximum charge drop to 0 charge, the maximum voltage V0 drop to 0 voltage. So you see the difference. Yeah? For charging, the Q and V increase. For discharging, Q and V decrease. Okay? So for charging, VC from 0 become V0. For discharging, the VC from V0 becomes 0. Okay? For charging again, the QC from 0 become Q0. Yeah, just like the VC from 0 become V0. For discharging, the Q0 becomes 0, just like the VC from V0 become 0. Okay, that's good. Now, let's talk about the current. Just now we already talked about the charge and the voltage. Okay, charge and the voltage. How about the current? Is it the same case? How about the current? How the current changes in the circuit? Okay. First of all, I want you to know one thing. Current only flow from high potential to low potential. Current only flow when there is a potential difference. If the electric potential between the 2 points is the same, if both points have the same potential, the current don't flow. The current only flow when there is a potential difference, always from high potential to low potential. It's just like the water. The water tank, the water must always flow from a very high position with high potential energy, flow to a lower position with lower potential energy. The water never flow from low position to high position. That's why our water tank, always we put the water tank on the roof. Yeah, on the roof. Or even our water tank is outside our house in the garden. The water tank also must place at a high position. Then only the water will flow from that high position into our house, which is at low position. Okay? Water always flow from high position to low position, from high potential to low potential. Same goes to current. Current must flow from high electric potential to low electric potential point. Okay? Current only flow when there is a potential difference between the 2 points. Good. Now, let's look at the charging process. Let's look at the charging process. When we first connect the capacitor with the battery, okay, we know that the battery itself already has very high voltage, but the capacitor is neutral, isn't it? It's neutral. The capacitor is neutral, so has no potential, no voltage, 0 voltage. VC is 0. So there exists a high potential difference between the battery and the capacitor. High potential difference between the battery and the capacitor. So there must be a current flow because there is a high potential difference between these 2 points, these 2 components. So there is a lot of current flows initially during charging process. A lot of current flow try to charge up the capacitor. Okay, because we know that electron pulls out. Yeah, electron pulls out the battery. The battery pulls out electron from one plate of the capacitor and then deposit the electron on the other plate. Yeah, so that one plate become positive, one plate become negative. So initially there is a very high potential difference between the battery and the capacitor because capacitor has 0 voltage, battery has the maximum voltage, so there is a high potential difference between them. So initially is maximum current. Maximum current because a big potential difference. Current likes to flow from high potential to low potential. So initially there is a big current flowing. Yeah, that means a lot of electron is being pulled out from the one plate, from the positive plate, and gather at the negative plate. Okay, it's just like the empty water tank. Initially, when it has no water inside, the water just gushing inside. It's like the water gushing inside try to charge up the capacitor. You know, the water gushing inside to fill up the water tank. So the water initially is like maximum. So it's like the water which flow inside is like current flow. Yeah, it's like maximum current. Yeah, so initially I is I naught. It's not the current is not like the voltage and charge. Initially voltage and charge is 0, but the current is maximum. Current is maximum because it's like water gushing in to charge up the capacitor. Okay, to fill the water tank. Understand? Because there's a very big potential difference between the battery and the capacitor. So sooner or later the water tank will full, and the water will stop flowing. Because of the the floater. There is a floater there to help to stop to gush the water. So in the end, no more water flowing in, isn't it? No more water flowing in. No more water flowing in. The water is just like the current. No more water flowing in, so the current becomes 0. It's like when the capacitor is being fully charged, the charge of capacitor become Q0. The voltage across capacitor become V0 also. When there is a maximum charge, maximum voltage, then there's no more current flow. Yeah, no more current flow because the charging process already stopped. The charging process already stopped. It's like the floater stopped the water from flowing in already. If the water still flowing in, this water tank will spill, or will overflow. Okay, yeah. Then this water tank you need to repair. Yeah, because it will overflow. So when the water tank is full, the water stop flowing. Same goes to the capacitor. When the capacitor is fully charged, QC become Q0, then the current also will stop flowing. Current become 0. Current becomes 0. Why current becomes 0? Look carefully between the potential between the battery and the capacitor. Battery has the voltage V0, maximum voltage. Capacitor also already built up the maximum voltage, also equal to V0. Both V0, both maximum voltage. No potential difference between the battery and the capacitor. When no potential difference between these 2 points, no current, no more current flow. No more current flow, because that's why I equal to 0. Okay? That's explain everything. So let's look at the graph for charging process. For charging process, the graph is you see, look at this one. For the charging process, the current actually is decreasing. The current is actually decreasing. Yeah, let's look carefully. So you look at this current for the charging process. For charging process, the current decrease. Initially, the current is maximum I0 because it's like the water gushing in. The water gushing, a lot of current flowing inside. But in the end, current becomes 0 because stop charging already. Stop charging. So that's why for a charging process, current is not increasing. Current is decreasing. The charging process is very fast, very furious initially. But when the charging process already done, the current will drop to 0. You see that? The current will drop to 0. So current decrease. Current must decrease. Okay? For charging process. Okay. And then let's look at you see. Let's look at the electron flow. Let's look. Actually, the current, I say just now about the current flowing actually represented by the electron flow. Represented by electron flow. So as you look here, this plate, the upper plate is connected to the positive plate, isn't it? Upper plate is connected to the positive plate. So electron is being pulled by the positive plate. Electron is being pulled by the positive plate from the upper plate of capacitor. So electron, the positive plate attract electron from the upper plate and then deposit the electron at the lower plate of capacitor. So that's why the upper plate become positive, lower plate become negative. So for this electron flow, the electron flow for charging process, it is anti-clockwise. The electron flow is anti-clockwise. Okay? Anti-clockwise. Now, let's look at the discharging process. Discharging process, look at the electron flow. Which direction? It's just like you already fully charged a capacitor. Now you remove the battery. Left with only the resistor. So what will happen if the capacitor only left with resistor without the battery? Without the battery, it's just if without the battery, it's just like you loosen the cork. Yeah, you open up the faucet. You open up a faucet. What happened? The capacitor will discharge. The water tank will start to flow out the water. Okay, is the capacitor will start to discharge. So electron will initially last time electron is anti-clockwise. Yeah, the electron flows anti-clockwise. You know the reason why the electron flow anti-clockwise, because the positive plate of battery pull out the electron from the upper plate. That's why the electron will flow anti-clockwise. Okay, the battery pull out the electron from the upper plate to deposit at the lower plate. Now this time, when you remove the battery, this negative plate electron will start. The electron will start to flow out from the negative plate to go back to the positive plate, because we know that electrons tend to go to the positive plate. Electron likes the positive plate a lot. Electron tends to go to the experience the electrostatic force to the positive plate. Yeah, electron will be attracted to the positive plate, or we can say electron will tend to go to the positive plate to neutralize it. So when you remove the battery, electron now will move from negative plate to the positive plate. Now the electron is flowing clockwise. Last time, electron flows from upper plate to go to the lower plate. Now electron flow from lower plate go to the upper plate. Last time electron flow from upper plate to lower plate, anti-clockwise. Now electron flow from lower plate to the upper plate. So now it's clockwise. So it's opposite direction. Do you see that? It is opposite direction. So how about the current initially? Is the current flowing very fast initially for discharging process? Of course, because now we are not comparing capacitor with battery. We are not comparing. Last time we are comparing capacitor with battery. Very high potential difference. Now we don't have a battery there. Now the electron here flows from negative plate to the positive plate is because of potential difference between the two plate of capacitor itself. It's because of potential difference of two plate of the capacitor itself. Okay, there exists a high potential difference between the two plate of capacitor, because one is positive plate, one is negative plate. Because the capacitor is already being fully charged. The voltage of capacitor is already maximum voltage V0. So when you have a big potential difference, when positive plate and negative plate, electron tends to flow, or the current tends to flow because there is a high potential difference between the two plates. Or in short, we can just say that electron want to flow back to the positive plate to neutralize it. Okay, neutralize it. Okay, electron will flow very fast. It's just like the water tank has a lot of water. When you open up the faucet, the water is gushing out like hell. Yeah, it's gushing out. So the current is like maximum I0. But once the water tank become empty, no more water inside, the charge becomes zero, no more water. Then no more water, what what kind of things will flow out anymore? No, nothing. So the current is 0. The water stopped flowing because no more water no more water in the water tank. Yeah, so the current also becomes 0. No water flow, no current flow. It's just like, because slowly this capacitor is being neutralized. Yeah, electron start to flow back from negative plate, go back to the positive plate. So bit by bit, the voltage of capacitor will decrease. So the potential difference between the two plates will start to decrease. You see that the voltage, the potential difference across the two plates will start to decrease. Yeah, this voltage is actually the potential difference. It's the potential difference between the two plates. The potential difference between the two plates will start to decrease. So in the end, both plates become same potential because neutral. So no potential difference. When no potential difference, no current flow. Yeah, as I said, current only flow when there is a potential difference between the 2 points. When they become the same potential already, neutral already, no more current flow. It's like empty water tank, no more water, nothing flowing out. Okay, so no more potential difference between the 2 points. The current also already become 0. That's what happened to the current in discharging process. You see the discharging process. For discharging process, the current also decrease. Okay, the current decrease. So for both charging and discharging, you look carefully. For both charging and look carefully. Yeah, for both charging and discharging process, the current decrease. This one, the current also decrease. Why? Now I want to ask you, why is it this graph is below the axis? Why the graph of the discharging process is below the axis? Why the current is below the axis? Whereas for the current in the charging process is above the axis. Why is it? You see that for discharging process, the current has a negative sign. It is because the current in discharging process is flowing in the opposite direction compared to the charging process. The current in the discharging process is opposite direction than the charging process. Why I say like that? You already learned just now. Look back to what you have learned just now. For charging process, electron flow from upper plate to the lower plate. So it is anti-clockwise, isn't it? Anti-clockwise. But for discharging process, electron flow from lower plate back to upper plate. Lower plate back to upper plate. It is clockwise. So the current, electron is just like the current. So the electron flow in the opposite direction in discharging process. Electron flow in the opposite direction compared to the charging process. This one from upper plate to lower plate. This one from lower plate to upper plate. So it's the opposite direction. That's why the current for discharging process is opposite to the charging process. That's why the graph for discharging process, the current for discharging process has a negative sign to show that the current is opposite direction to the current to the one in the charging process. Charging is positive, current is negative. To show that both of these current between the charging and discharging process, they have opposite direction. This one is from upper plate to lower plate. This one is from lower plate to upper plate. Okay? But of course, during the calculation, you just ignore the negative sign in the equation. We just want to find the magnitude of the current at any time. All right? Okay, before we go to the, there's one more thing I want to talk about the resistor. I have a lot of concepts to talk. For the resistor, I want you to know one thing, yeah? You know, this resistor and this capacitor, they are in series connection. Yeah, if you look at that, you look at between the resistor and capacitor, they are in series. Why they are in series? Because they have a one leg connection, isn't it? One leg connection. The other leg connect to the battery. Connect to the battery. So we can say the EMF is equal to VR plus VC. The voltage is just total up, isn't it? VR, voltage across resistor, plus voltage across capacitor is actually the voltage of battery. This is for series connection. Okay. Of course, the voltage EMF we can write as this way. Yeah. Sorry. Just wait a minute. Okay. Now I want to look at one thing. This we can say this EMF is just like V naught lah. It's just like this EMF is actually V naught. Okay, it's actually V naught. Okay, so I want to look at the charging process. Initially, we know the capacitor is zero voltage. Zero voltage because it's neutral, isn't it? Zero. So that's why for this equation, the VC is zero. For initially VC is zero. So that's why the VR is equal to V naught. That's why our VR equal to V naught because our VC is zero. You must remember E equal to VR plus VC. But for initially, our VC, voltage across capacitor, is zero. So the VR inherit all the voltage from the battery. So VR equal to V naught. Also, if you look at the equation, actually, the current flowing through the resistor, we have a V equal to IR, isn't it? V equal to IR is the maximum current. Maximum current multiply the resistor. That's why we have the maximum voltage across the resistor. Because right now, initially, in the circuit, we have maximum current. We have maximum current flowing because initial process the current is maximum. I naught multiply resistor. That's why also we have maximum voltage across the resistor. But after finish charging, the capacitor become the maximum voltage V naught. So what happened to voltage across resistor? What happened to voltage across resistor? So the is inverted, yeah, is opposite to what happening. Now V's in the end, VC become maximum voltage. So now our VR becomes zero, because our VC already become maximum voltage. Do you see that? Our VC become maximum voltage. The capacitor now inherit all the voltage. So voltage across resistor now become zero. Voltage across resistor now becomes zero because the capacitor already take up all the voltage from the battery. Okay. Also one more thing, because the current now is zero. Now last time the current is here. Current is maximum. Current is maximum. So that's why maximum current multiply resistor, we have maximum voltage across resistor. Now this time, after finish charging, no more water flowing into the tank. That means it's like current is zero. No more current now flowing in the circuit. No more current flowing in the circuit. So when VR equal to IR, so when current zero multiply resistor, zero times resistor, that's why voltage across resistor zero also. Yeah, because it's just like zero current multiply resistor because the charging process already finished. The current already becomes zero. Zero multiply resistor, you get zero voltage across the resistor. Understand? Now let's look back to the discharging process. When you look at the resistor, same thing goes to initial process. Initial process has the maximum current, yeah, or you can say it has the maximum current initially. Yeah, maximum current initially. That's why maximum current multiply resistor. I naught times R, you have the maximum voltage across the resistor. And the capacitor also have maximum voltage. This time, because we don't have battery. So our voltage across, we can say resistor and capacitor now in parallel. Last time our resistor and capacitor, they are in series. Resistor and capacitor in series, but now our resistor and capacitor, they are parallel. They are now in parallel, so it's different. Okay, they are now in parallel. So that means if both of resistor and capacitor now in parallel, that means the capacitor, whatever voltage of capacitor, the voltage will be the same as voltage across resistor. So that means both, because our resistor and capacitor now in parallel, so the voltage of resistor is equal to voltage across capacitor. Because now capacitor is being fully charged, it has the maximum voltage. Since the capacitor now has the maximum voltage, so VR also has the maximum voltage because they are in parallel. Understand? Another way to look at it is, because there are maximum current flowing in the circuit now, so the maximum current multiplied resistor, that's why we have the maximum voltage across the resistor also. Yeah, we have maximum voltage across the resistor and maximum voltage across the capacitor also. Both have the maximum voltage because both of them are parallel. They have the same voltage. Enough of that. Okay, now let's look at the last thing. Now finally the capacitor has been fully neutralized. It's being back to neutral again. So voltage across capacitor now becomes 0. So when voltage across capacitor, when voltage across capacitor now back to 0, when voltage across capacitor now back to 0, so voltage across resistor also 0. Okay, because resistor and capacitor, they are parallel. So if the capacitor has 0 voltage, so resistor also has 0 voltage. And another way to look at it is, because at here, no more, the water tank is empty, no more current flowing. So the current is already become 0 here. The current already becomes 0 here. So it's like when you use the formula V equal to IR, it's like 0 times resistor, you get 0. Okay, you get 0. So voltage across resistor is 0. Okay. So that's it for I think everything about this charging and discharging. Next, we look at the formulas. Okay, thank you.